Hello everyone. Today we will be talking about micro switches, specifically those which were on this little board. This board came from an old mouse and it was given to me by Tobin, so thank you. And it contains 3 of these little micro switches which were used to actuate the buttons. These 2 for the buttons, and this one was probably for the scroll wheel because I guess some mouses you can press down on the scroll wheel and it will activate a switch or something. But anyway, these micro switches here are quite a bit different from regular push button switches, of course, just because they're a different shape. They also have 3 terminals, a bit more like a slide switch and not a push button. And of course, they also make a very distinctive clicking sound. Not sure how well you can hear that, but you probably can. So this clicking sound comes from the fact that they have some actual little mechanical bits inside. And I am excited to take a look at one of these, maybe take a look at the electrical characteristics of them, just how this 3-pin design works. But anyway, I think it's about time that we desolder them, or at least one of them, so that we can get a closer look. And would you look at that? The small switch is desoldered. And of course, those are your 3 pins, and it still clicks like normal. So let's go ahead and measure the electrical characteristics of it with my cheap portable multimeter. I do have a better multimeter than this, but it's a benchtop multimeter, and it's also quite old, so it doesn't have this fancy little continuity beeper on it, so it's a bit harder to use. And this one, it's just better for this application. So let's go ahead and put it on the continuity mode and see what happens when we push the button. You hear a clicking sound. So this means that we are currently connected to a common and a normally open contact. So when you press the switch, the normally open contact closes and you hear the beep. Let's go ahead and switch this black one. And now it's beeping when it's not being pressed, and when I press it, it stops. So this must be the normally closed contact. It's closed when it's not pressed, and it's open when it is pressed. So then what happens when you just go between the normally open and normally closed contacts? Nothing. I press it and nothing's happening. Ignore any hissing sound that you might hear. That's just a water heater doing its thing. But anyway, let's go ahead and take this thing apart. It doesn't seem too hard to take apart. It's just got some little bracket over there which would need to be undone. So let's zoom in and see if I can take this thing apart. So I'm just pushing a tweezer into that little gap over there, and it should be coming off. All right, well, it's kind of off. Okay, well, now it's cracked open. Now I guess I should do the other side. This is quite dodgy. I really don't want the tweezer stabbing me, but, well, it's open. And apparently this little actuator, this little white plastic button, it's just in there and it falls out quite easily. So here is the little switch. And when I go ahead and press it in the right location where the button would have been pressing, it makes that distinctive clicking sound. And that is because this main little piece of metal over there is basically acting as a spring. So when I press it, it kind of springs back between 2 different positions. And if you look at those contacts on the right, you can see that it moves up and down very, very decisively. And it's definitely quite a bit better than a typical push button in that case because it goes very quickly and it probably has little to no bounce. And bounce is just where the contacts quickly connect and disconnect, which usually isn't an issue for typical simple analog circuits, but for digital circuits, the circuitry could register that bouncing as multiple button presses, so you definitely wouldn't want that in a mouse, for example, where you just single click and it double clicks, or it registers it as double click because the switch bounced. And also the mouse and the switches need to be clicky to get that nice tactile feel, and the micro switch solves both those problems. Although I won't be surprised that there's probably still a little bit of bounce in that little contact, so a debouncing circuit is probably necessary a bit further down the line. Now let's see if I can put this thing back together. So let's go ahead and take or put this little button back into the housing, if I can get that. And let's insert it in there. And now I should be able to take the switch body and just snap it in there. And does it still work? Well, yeah. I mean, I guess I was expecting it to have a lot more mechanical pieces inside that would be very hard, if not impossible, to put together. But I guess it really isn't all that complicated. So I guess that is about all that I have to say for this mighty little micro switch.